We've been doing a lot of experimentation with AI agents. We believe the ability for these agents to have agency to perform actions on your behalf is really powerful and has lots of applicability within telcos. Also, we've been experimenting with multi-agent architectures. So if you have a big problem, the notion of breaking it down into small agents and have those agents collaborating to solve a problem, we find that works much more effectively, because for an agent to be successful, it needs to have a really well-defined and ideally a small scope and a small set of tools that it can use to perform its action. Now, jointly with Google, we asked our question of, what if in a multi-agent architecture, you had agents from different organizations talking to each other and communicating and collaborating? And this is building on the concept which is existing now for many years in the world of APIs. So when we built our API first strategy, one of the concepts was, even if I build an API just for my website to connect to a billing system, for example, if I design that with an API first way, I really carefully design that API. And I don't just consider that one use case. I think, well, this API might be used by other use cases, including external partners integrating with that same billing system. And so we asked the question of, what if we applied the same sort of concepts to AI agents? And this is the collaboration that we presented at DTW earlier this year. And it was a collaboration between Vodafone and Google Cloud. And the concept was, within the TM-Form Innovation Hub, we've been developing something called Aiva, or the TM-Form Virtual Assistant. We actually launched this in June 2024. So we launched the portal. It's live on the TM-Form website. You can go and ask Aiva any questions about the TM-Forum. And behind it, there's a RAG database. And so it's not just answering those questions from its training, it's actually retrieving relevant contextual information, and you get really high quality answers. And those answers also have citations, so you can go and find the relevant documents within the TM-Form collaboration. And then within Vodafone, we developed a separate agent, which is an internal agent for enterprise architects. So it's a tool for enterprise architects to help them perform their role. And it's called AI for EA, AI for Enterprise Architects. And the question we had was, could I have the Vodafone Enterprise for EA agent actually collaborating with TM-Form Aiva if my enterprise architect within Vodafone has got a problem which includes the use of TM-Form assets? This is an overview of the architecture. So the concept is, on the Vodafone side, we're building agents. Actually, we built multiple agents because we had a multi-agent architecture on the Vodafone side. And we had a supervisor agent and then multiple local agents. And you could build these in any technology. And actually, we built them using Langflow, using LangGraph, and using the Google ADK, which is their open source agent development kit. And so the Vodafone agent, it had access to local Vodafone knowledge, APIs and enterprise applications through MCP, but also was able to communicate with the TM-Form agent. And this agent, again, it's a multi-agent architecture. So there's a supervisor agent and multiple local agents. And this, again, could be built in any framework. And this agent has access to a whole suite of TM-Form standards documentation. And they can communicate and collaborate, and we're embracing open standards. So we're using MCP for the agents to interact with tools, and A2A for the agents to interact with other agents. And this is the architecture of the Vodafone agent. So as I said, the Vodafone AI for A is actually a supervisor agent. There's a nice web user interface, which I'm going to show in just a minute. And then the supervisor agent can actually collaborate with multiple sub-agents. So each of these sub-agents has a specialist skill and it has its specialist tools and access to specialist data to help it perform a particular part of an enterprise architecture role. And this is a modular and extensible architecture, and we will be adding to this over time. At the moment, this is still a proof of concept, but we are intending to take this from proof of concept into trial and roll it out across the enterprise architects within Vodafone. And then, as I said, this supervisor agent, it also has knowledge of the TM form Aiva, so it can reach out to Aiva if the question you ask it has any relevance for the TM form standards. And this shows what it looks like. This is a view of that interface, and you can see, so this is the web version or the web portal on top of AI for EA, and these are the sub-agents. The little green dots show they're connected properly, and we've got sub-agents for API discovery, gap analysis, schema generation, diagram generation, and then finally we've got Aiva. So this is the TM form Aiva agent, which is registered and is available for AI for EA to use. And I can show it as a demonstration. If I click this link. So this is the web user interface, and I've asked it a simple question. So what is TMF 654? Can I reserve a balance for a future scheduled date inside TMF 654? Is this a gap? So I'm asking a question of the standards, but I'm also asking a question of, this is, for my particular use case, is this a gap? And you can see it's reached out to Aiva, because I'm asking about the standards, who's reached out to ask a question to get like the industry knowledge about that API. And now it's going to a different sub-agent, which is a gap analyzer. So this is an agent with special skills to analyze a use case and see if it's a gap. And what it's come back with, it says, actually, looking at the existing capabilities, there is a gap. So it doesn't explicitly include functionality to schedule a balance reservation for a future date. And it's even then proposed a solution to address the gap. And then I've asked, generate a JSON scheme for this extension and generate a plant UML diagram for version 4.1. And you can see, so it's going through and it's doing the JSON schema modeling for that extension. So I'm actually building an API extension, and it's generated this diagram, and this white bit, that is showing the extension. So this is the normal TMF 654, and that white bit was the extension. A very quick demo of this agent, or this multi-agent architecture in practice. And then one further point, because we embraced open standards and these agents, they're all developed as atomic composable agents, it gives us a lot of flexibility. So as well as using like the Vodafone portal and the supervisor agent to interact with these other agents, you can actually use any agent to interact with them. And so we're demonstrating it with coding assistants and third-party agents. And using this MCP open standard, I can integrate these sub-agents into my coding assistant. And then when I'm actually doing architecture work, so I'm actually generating schemas or I'm doing my architecture work in a GitHub environment, I can get these agents to do work for me just by expressing the outcome that I want. And these coding assistants, they're the most powerful AI agents available today. And they're able to interact with these sub-agents to help actually perform those actions. And it just shows the power of a modular design and also embracing these open standards. So what benefits did we gain from this? So these are the benefits we're anticipating. So this is still in the proof of concept phase, but we're anticipating, and what it's already showing us is it can accelerate our digital transformation. So enabling faster, more consistent architectural decisions aligned to our enterprise strategy. There's a big efficiency play. So it's boosting productivity and in artifact creation, and it's very scalable. We have a skills challenge, and actually have these agent tools to support enterprise architectures really helps in education and addressing some of the skills challenges. There's a risk reduction in compliance. So when we're identifying architecture gaps, like the agents they're built to address them in the correct way. So we've embedded our strategy, our API first strategy, and our adoption of industry standards into the agents. So naturally, as part of their role, they'll be very compliant with our standards, and therefore this is a risk reduction benefit. We think this will drive innovation. So it enables you to be much faster and to do agile experimentation and supporting these emerging technology patterns. It's preserving our institutional knowledge. So as part of this work, like when you build these agents, one of the things you find is you do have to be more organized about the data. So these sub-agents, they're all based on Vodafone internal data, you do have to rethink how you organise your institutional knowledge. We're embedding it, and it becomes like a virtual cycle of using an agent, and you're learning how to use it, and you improve the underlying data. And finally, the business value is we're shortening the time to value because we're removing any bottlenecks, and we're more quickly able to align our IT with business needs and supporting value-driven decisions. Okay, thank you for your time.